Welcome, everyone. Today, we are diving into a fascinating paradigm shift in the world of AI. Why are complex abstractions failing enterprise automation? And how does direct API interaction win the cost-performance trade-off? The short answer, based on research by ServiceNow, Mila, and the Université de Montréal, is simply this: terminal agents suffice. Let's unpack exactly what that means. Let's look at the current landscape. When we connect foundation models to enterprise data, we generally force them through heavy abstraction layers. On one side, we have GUI-driven web agents. They navigate raw user interfaces, which makes them highly flexible, but they are incredibly brittle and plagued by constant UI changes. On the other side, we have tool-augmented agents using frameworks like the Model Context Protocol, or MCP. These give the AI curated action schemas. They're simple to invoke, but they strictly restrict the agent's expressivity to predefined operations. So, we have to ask, are these costly, heavy abstraction layers actually necessary when modern enterprise platforms already expose highly expressive APIs? This brings us to our hypothesis: less is more. What if we use a minimal coding agent equipped with nothing but a terminal and a file system? In this alternative paradigm, the interface is just a REPL-style loop: plan, execute, inspect, iterate. The agent generates shell commands and uses tools like Python or curl to interact directly with stable platform APIs, like GitLab, ServiceNow, and ERPNext. It manages its state, reads documentation, and saves its skills right in the local file system. When we compare these paradigms side by side, a clear winner emerges. Look at this matrix. Web agents give you high flexibility, but operational costs are extremely high, and they easily fail when getting lost in nested frames or pop-ups. MCP agents keep costs low, but flexibility is practically non-existent. They are tightly bounded by tool design and fail when endpoints or fields are missing. But the terminal agent? It gives you the best of both worlds. It has high flexibility because it can compose arbitrary payloads dynamically, combined with a low operational cost. Its only real failure mode is when features are strictly tied to browser session cookies. Let's see this showdown in action with a simple prompt: order one iPad Pro from the catalog. The MCP agent hits a dead end fast. It finds the item, realizes there's no specific ordering tool, tries to create an incident ticket as a workaround, and ultimately fails. The web agent enters a maze. It gets confused by an iframe, enters a frustrating loop of clicking and waiting for 16 steps, and submits an incomplete order. But the terminal agent? It explores and adapts. It queries the API, hits a JSON quoting error, dynamically fixes it by writing the payload to a temporary file, tries alternative endpoints, and finally places and verifies the order. Success in 11 steps for just 78 cents. To prove this wasn't just a fluke, the researchers built a massive evaluation benchmark featuring 729 realistic enterprise tasks. These tasks covered ITSM on ServiceNow, software development on GitLab, and ERP on ERPNext. They tested top-tier foundational models, including Claude 3.5 Sonnet, Claude 3 Opus, GPT-4o, and Gemini 1.5 Pro, all evaluated in isolated, containerized sandboxes with programmatic verification. The verdict is in, and it's definitive. Terminal agents consistently occupy the magic quadrant of the optimal trade-off zone. Look at the Claude Opus comparison. The terminal agent matches the web agent's accuracy, nearly 80%, but it does so at roughly one-third of the cost, dropping from nearly $4 down to $1.22. And if we're talking about the peak of efficiency, Gemini Pro powering a terminal agent achieved a 77.5% average success rate across all platforms at an astonishing 9 cents per task. Meanwhile, the cheap MCP agents lag severely behind in accuracy, often failing to reach even a 40% overall success rate. Why does MCP fail so badly? We call it the abstraction trap. It's the false promise of tools. A raw API might have over 100 capabilities and fields. But an MCP tool schema acts like a rigid, narrow funnel. If a create_incident tool only exposes 5 parameters, the agent is structurally blocked from completing tasks that require the underlying API's other 45 fields. Terminal agents bypass this wrapper entirely. By hitting endpoints directly, they compose arbitrary payloads on the fly and utilize the entire capability of the API. And why are web agents so expensive? It's the token tax. Mimicking human flexibility requires processing massive accessibility trees, DOM elements, and rendered screenshots. A simple task like sorting a list requires 30 to 50 discrete browser actions, clicks and waits, which drains token limits and drives up costs. A terminal alternative achieves the exact same sorted result in milliseconds with a single API call, just by appending a query parameter to the URL. That's why a web agent can cost $6.49 per task on ERPNext, compared to just 72 cents for the terminal. Now, terminal agents aren't perfect. So where do they break down? Interestingly, task failure isn't caused by shell errors or bad tool syntax. Agents actually recover from those easily. They fail at hard structural limits. Specifically, UI-exclusive state, like impersonating a user, which requires a browser cookie exchange that APIs can't replicate, rendered abstractions, where extracting values from a front-end dashboard chart doesn't perfectly match the raw aggregated API data, and complex visual editors, like drag-and-drop workflow builders that simply don't have a one-to-one API equivalent. But terminal agents have a unique superpower: learning on the job. By giving the agent a local directory to read and write markdown notes, isolated execution transforms into cumulative learning. The impact is huge. On highly idiosyncratic platforms like ERPNext, accuracy jumped 5.8% as the agent mapped out undocumented dependencies. And the cost impact? On ServiceNow, the average per task cost plummeted by 43.7%. The agent stopped wasting tokens on API exploration and started remembering the exact schemas it figured out previously. Let's look at the anatomy of one of these self-generated skills. Once a procedure is verified, the agent documents it for future use. It translates human UI labels to programmatic API fields, like mapping impact, high to the number 1. It documents platform quirks, like discovering that setting so_acquired equals 1 actually has inverted semantics, meaning it allows invoices without sales orders. And it notes infrastructure-level shell gotchas, reminding itself to never inline multiline JSON, but rather to write it to a file to ensure future stability. You might assume that handing the agent the official API documentation would always help, but we found a documentation paradox. On ServiceNow, giving the agent reference docs actually hurt performance by 6.3%. The official docs acted as massive catalogs, distracting the agent into complex, multi-step endpoints instead of discovering the simpler, atomic options. However, on ERPNext, task-oriented docs boosted performance by 4.7%. They provided conceptual scaffolding. They didn't give the exact code, but they prompted the agent to search the API schema for the right field, solving ambiguous UI labels. What about combining these approaches into hybrid or multi-agent systems? The verdict is underwhelming. Planner and executor models offer only modest gains, and really only help weaker models. Strong models, like Opus, internalize this planning naturally, making the multi-agent overhead completely unnecessary. As for hybrid systems combining a terminal and a web browser, models struggle with routing failures. Given the choice, they aggressively default to the expensive web browser for simple data operations 82% of the time, unnecessarily inflating costs up to $3.02 instead of keeping it at 78 cents. So, let's synthesize our conclusion. The real bottleneck in enterprise automation isn't a lack of complex agentic frameworks, it's the APIs. Direct is better. Direct programmatic interfaces combined with strong foundation models yield peak efficiency, slashing token costs by up to 5x. Wrappers restrict. Tool registries like MCP trade crucial programmatic flexibility for unnecessary structure, blocking LLMs from composing novel solutions. Ultimately, the future is API first. We need to stop building heavier web scraping agents. The future of agentic enterprise systems relies entirely on exposing stable, expressive, and direct APIs. Thank you for watching.